Bismillahirrahmanirrahim. Assalamu alaikum. Hi guys. Today I will solve another geometrical challenging problem. And before starting the problem, please subscribe my channel and press the bell icon button. Now we start the problem. Now the problem is here. The diagram shows a semicircle with center O and the radius 2 and the semicircle arc with diameter PR. What is the area of the shaded region? Now you see here the semicircle arc. This is the semicircle arc and the diameter is PR. Now firstly, we draw the diameter. You see here, this is the diameter. Now after mention the diameter, we will find the length of PR. You see here, this is the triangle, right angle triangle POR. Now in right angle triangle, POR, the length of PR we can calculate by using the Pythagoras theorem. In this Pythagoras theorem, the hypotenuse square will be equal to base square plus altitude squares. This is the hypotenuse and this is the base and this is the perpendicular. Therefore, the hypotenuse square will be equal to base square plus perpendicular square. Now you see here the hypotenuse length is PR square and base length is PO, that is 2 square. Now the perpendicular length you see here, this is OR. Now this length OR will be equal to this length OP because OR is also the radius of this semicircle. Therefore, we can write it this length is equal to 2. Now, therefore, the perpendicular length is 2 whole square. Now, that value will be equal to 4 plus 4 and that's equal to 8. Now, PR square will be equal to 8. Now, we take the square root on both sides. We get PR will be equal to square root of 8. And therefore, PR will be equal to square root of 8 can be written as 4 into 2. Therefore, PR will be equal to 2 under root 2. And this is the diameter of this semicircle of the arc PR with diameter PR. Now we can find the radius of this semicircle having diameter PR. Suppose the radius we name it as small r. This radius will be equal to PR over 2 and that will be equal to 2 square root of 2 over 2 and therefore we can write it as square root of 2. Now the area of this shaded region will be equal to area of this semicircle minus area of this segment. This is the segment. You see here this segment. Now we write it as area of shaded region will be equal to area of semicircle having diameter PR minus area of segment POR. Now this area of segment POR will be equal to area of sector POR minus area of triangle POR. Now this is the sector POR and this is the triangle POR. Now we write the area of semicircle having diameter PR. That value will be equal to 1 over 2 pi r square. And this radius is, you see here, square root of 2. We can write it as square root of 2. And that's equal to 1 over 2 into pi into square root of 2. Next is the area of sector POR. This is the sector POR and this is the quarter circle. Therefore, the area of this quarter circle will be equal to 1 over 4 into pi r square. Now, suppose the radius of this sector is capital R. Therefore, 1 over 4 pi r square minus area of triangle POR. You see here, this is the triangle POR. Therefore, that's value will be equal to 1 over 2 base length into height. Height is OR. Now we substitute the value here. 1 over 4 into pi into radius of this quarter circle is capital R, that's equal to 2 square. Now you can write it as 2 square minus 1 over 2 into PO length. You see here is 2 and OR length is also 2 because this is also the radius of this semicircle. Therefore, we write it as 2. Now you see here we can write it as 1 over 2 into square root of 2 square will be equal to 2 into pi minus, you see here 1 over 4 into 2 square is equal to 4 into pi minus 2 ones are 2 and 2 ones are 2. Therefore, we get only 2. Now you see here 2 times 1 is 2 and 2 times 1 is 2. Therefore, we get pi. And same here is 4 times 4 ones are 4 and 4 ones are 4. We get pi. And same here is minus 2. Now that's area of this shaded region will be equal to pi minus pi plus 2. And pi will be cancelled. Therefore, this area of this shaded region equal to 2 units squared. And this is the answer.